From Los Alamos National Laboratory, this is the National Security Science Podcast.
After you check the glove for conditions, then you get in.
You do both hands at once.
You can, yes.
I don't think I can.
Get in and go across the front of your body.
Yeah. This is so hard.
Welcome to the National Security Science Podcast, the podcast for Los Alamos National Laboratory's National Security Science magazine. I'm your host, Brenda Fleming. In today's episode, we're talking about knowledge. That's the focus of the next issue of our magazine and a key component of the work that goes on at Los Alamos. In the magazine, you'll find articles about learning, knowledge management, mentoring, and more. For one story, National Security Science magazine writer Jill Gibson tried her hand at learning to work in a glove box. Glove boxes are sealed enclosures that some lab employees use when they are working with hazardous materials. Jill is joining us to explain what that's like and what training workers go through to prepare for this work. Jill, I understand you got a real hands-on experience working on this story.
Yes, I did, pun intended. It was a first-hand look at what it takes to use a glove box.
Now, glove boxes are used with various hazardous materials, but the training program you wrote about is focused on teaching people how to work with plutonium, right?
That's correct. Glove boxes are sealed glass and steel compartments inside which radioactive materials are safely handled. Long, heavy gloves are attached and secured to the openings of the glove box, and technicians insert their hands into the gloves to carry out a wide variety of processes. One of the most important processes that requires glove boxes is the making of plutonium pits, the cores of nuclear weapons. Technicians purify plutonium, cast it, machine it, measure it, test it, and much more, all with their hands inside these protective enclosures. So I wanted to find out how it felt to use those gloves.
And I understand that the lab has a special facility and program for training and certifying new glove box operators.
Yes, it's called NET, which stands for New Employee Training Academy. Kristen Cisneros is the manager. She says the program launched in 2020 to boost efficiency and training speed.
This is the only facility like this in the nation. You cannot bring in anybody that has the skill set that we need to build. So NET Academy is vital in providing that foundation for safety, for security, and for the work that they're going to be able to do.
How many people have been trained at NET Academy?
They've trained several hundred people so far. Amanda Quintana is in charge of the technical trainers who conduct the glove box training. She says all of the trainers are experts in their field.
Our technical trainers each have 20 years of experience in a nuclear facility, each, because they really have been on the floor. They've worked in PF4, in CMR, and at different nuclear facilities. They really can bring that expertise. So they're the ones who say, yes, we believe this individual is capable. We believe that they have the knowledge to move forward.
So for this story, Jill, you were assigned a trainer?
Daniel Garcia, a trainer who is extremely knowledgeable, kind, and patient, was assigned to train me. He's been at the lab for more than 3 decades and spent many years working with plutonium using a glove box. Before the training started, Daniel and I chatted about his teaching approach.
As that role as a technical trainer, it essentially made me able to communicate and teach new employees and existing employees on the requirements to perform their work safely and securely. I get the enjoyment when students have those aha moments. They're like, oh, now I know what that means. This role that I currently have, I have to essentially learn how to read people and their expressions and their communication styles. I'm able to figure out if they're having certain types of uncertainties. I can find a way to communicate the training so that they can understand it.
Sounds like he knows his stuff.
Absolutely.
Did you have to study and take tests?
I didn't, but employees who are really training to become glove box operators certainly do. In addition to assigned reading, they have hands-on instruction sessions, and they have to take oral and written tests and demonstrate proficiency performing tasks. I'll be honest, I skipped the studying and went right to the cold lab, a room built to look very similar to the labs in the Los Alamos plutonium facility, but without any radiological material.
So, Jill, tell me, what was the first thing you learned as a glove box operator?
The first thing I learned was how to put on my personal protective equipment, the PPE. I had coveralls, booties, safety glasses, and even gloves that I wore under the actual glove box gloves, which Daniel helped me tape to my coverall to prevent any openings that possible radiological contamination, that is, pretend radiological contamination, could penetrate.
So what you want to do is you want to place between the coveralls and your glove and tape it on you. So I'll show you on this side. Are you left-handed or right-handed?
I'm right-handed, so you do the left.
I'll do the left. So then you just put it here. And what you're doing, you're getting part of your glove and part of your coveralls, and you put the tape over. So with your safety glasses, go and put on your safety glasses. And those are required for the PF4 lab rooms.
At this point, I was ready to head to the lab, but Daniel briefed me on all the protocols and safety checks required before we could enter the room. There are many different things glove box operators need to check before entering the lab.
When you enter, you're in a radiologically controlled area. Before you enter the PF4 lab room, you're going to look for two things. You're going to look for the red light and the rad barrier. What these communicate is restrict access to the room. That means it is controlled for radiological or access purposes. You begin the task of verifying the doors for your PF4 lab rooms. And that is going over all the postings. I won't go over postings with you, but it tells the individuals who work in the room the current status of the room as far as requirements and conditions for transit combustibles, health hazard communications. So this tells you what hazards are in the room, as well as the visitor entry requirements, which you did.
And you couldn't just ask Daniel to jump ahead for the sake of the story now, could you?
Well, as you can hear, he takes safety very seriously, as does everyone at Los Alamos. Daniel wasn't about to skip a step.
So let's back to this one. Sorry for going back and forth. So we have two types of two-person zones, and they have to maintain that. The next posting we have here is the transient combustible check. The permit for the room is the allowed transient combustibles for the room, which is there for daily use operations. So all these things have to be followed and be aware of those requirements. Next thing we go, we have room status cards, which shows the status of the room and the allowable activity. Next thing we would check is if your room is released for uncleared workers. If the next work shift has uncleared, the same process has to occur to sanitize the room.
I'm already tired and we haven't even gone in the room.
Next, we have our radiological postings, which tells you what kind of areas you're entering.
After that, you're ready to look to the door. But what you're looking for in there, you're looking for any abnormal conditions.
Eventually, we did make it into the lab where he showed me how to check the air monitors and the pressure settings on the glove boxes. Next, we checked the glove boxes and gloves for possible radiological contamination. He explained that workers have to inspect everything before and after work.
So you want to check all available surfaces for contamination. I will then grasp it, begin swiping for contamination, swipe, and check. After you check the surfaces, you'll then check where the fingers are. So after you check the contamination, then you would look at the glove surface and check for any damage.
Okay.
And being that we already surveyed for contamination, we were able to more effectively check for any abrasions, discoloration, wear, breaches.
And then you could check your surface of the glove box of where you're pushing up against it.
So how long does it take the average person to even prepare to start doing work?
It should take almost 10 minutes. You're not only doing it for yourself, you're doing it for your coworker.
Finally, Daniel gave me permission to insert my hands into the gloves attached to one of the many glove boxes in the room.
After you check the glove for conditions, then you get in.
You do both hands at once, huh?
You can, yes.
I don't think I can.
Get in and go across the front of your body
Why is this so hard for me? I thrust my hands into the gloves and pressed my stomach against the box so I could see inside of it, all while trying to imagine myself carrying out a task inside the box wearing the gloves. It's hard to see if I was doing something right here.
Yes, exactly.
It is kind of hard to see.
It's hard to see in different positions, so you have to learn how to work in your area.
During the actual glove box work, operators run machinery and carry out processes within the enclosures. But for this first training session, my glove box was empty. Daniel puts his hands into a set of gloves beside me and hands me a roll of tape, instructing me to pick it up.
You need to do a power grip, which is you wrap your fingers around it, and not a pinch grip. You don't want to pinch things because that's where we're going. The thickness of the gloves can create stress on your fingers and your hands.
Yeah, this would get tiring.
Yeah, imagine doing that for quite a while, for
How many hours
days.
at a time would you be doing?
I probably do maybe an hour or two at a time, depending what the task is.
Jill, it sounds like you were struggling a bit. I guess it takes a while to get the hang of working in the glove box.
It does. Daniel pointed out that ergonometric experts work closely with the glove box operators to help them develop effective techniques and avoid any strain or injury. He also said that the people he trains tend to be very enthusiastic and excited about getting the hands-on glove box experience and are eager and ready to put in the time it takes to develop proper techniques.
Well, Jill, maybe you should stick to writing magazine stories.
I think you're right. But I was glad I could gain some knowledge about glove box training for National Security Science Magazine's knowledge issue. And I did learn that I still have a lot to learn.
Speaking of knowledge, have you ever watched the television game show Jeopardy? That's all about knowledge.
Of course, I even try to play along at home.
Magazine writer Jake Bartman did a piece for this issue about the time Los Alamos National Laboratory was one of the question categories on the show. Here's Jake with a chance for you to test your knowledge about the lab.
On May 28, 2014, the Los Alamos National Laboratory was one of the question categories on the television game show Jeopardy! Prompted by short videos filmed at the laboratory, contestants answered questions about some of Los Alamos' signature scientific facilities. How would you have performed if you'd been a contestant on the show? Remember to phrase your answer as a question.
From Los Alamos National Laboratory in beautiful northern New Mexico, this is Kind of Like Jeopardy!
For $400, at the heart of the Neutron Science Center is a powerful linear accelerator that accelerates protons to 84% of this, the C in E equals mc squared.
What is the speed of light? At the kilometer-long Los Alamos Neutron Science Center, or LANCE, protons are accelerated to 800 million electron volts, where they're used for everything from probing the structure of atoms to science that directly supports national security-related research and development. LANCE celebrated its 50th birthday in 2022, and in the next few years, the LANCE Accelerator Modernization Project is slated to replace the entire front end of the accelerator, ensuring that the facility will support vital research for decades to come.
For $800, when Trident is active, its 3 beams produce in 500 quadrillionths of a second the equivalent of 200 times the electrical output capacity of the United States. It's a type of this beam device first suggested by Einstein.
What is a laser? At the Trident Laser Facility, researchers used Trident, which was built in the 1980s, to conduct important inertial confinement fusion research, which involves heating and compressing small capsules of nuclear fuel to initiate nuclear fusion. The final Trident experiments were completed in 2017, and the laser has since been decommissioned.
For $1,200, a Los Alamos Operations Center monitors instruments that help this craft that landed on Mars in 2012 analyze rocks and soil.
What is Curiosity? For some 13 years, Curiosity has roamed Mars' surface, traveling a total of more than 22 miles. Los Alamos developed Curiosity's ChemCam instrument, a laser that zaps rocks and enables researchers to analyze their elemental composition. Among other findings, ChemCam has helped establish that Mars' surface once featured shallow, salty ponds.
For $1,600, the National High Magnetic Field Lab owns a world record. Its magnet reached the goal of 100 of these magnetic units, named for a European-American scientist.
What are Teslas? The National High Magnetic Field Laboratory, or MagLab, is the largest and highest-powered magnet laboratory in the world. MagLab comprises 3 sites at Los Alamos, Florida State University, and the University of Florida. These facilities help researchers understand how materials behave under extreme magnetic fields, probe the behavior of biomolecules, analyze the atomic structure of rocks and minerals, and more.
For $2,000, the lab's 3D visualization theater uses 33 digital projectors to study complex physical systems. For example, the asteroid impact that created the Chicxulub crater on this peninsula, leading to the extinction of the dinosaurs.
What is the Yucatan Peninsula? Los Alamos is home to some of the most powerful supercomputers in the world, machines that are used to produce simulations of everything from protein folding to nuclear explosions. At the laboratory's Cave Automatic Virtual Environment, researchers and visitors don 3D glasses and experience some of these simulations as immersive experiences produced by high-definition projectors. That's all for this week's show. So long, and thanks for playing.
Thank you, Jake. For the record, I got them all right. How about you, Jill? How'd you do?
Let's just say that I was better at answering the Jeopardy questions than using the glove boxes. Of course, I did have the answer key.
Well, that's all for this episode of the National Security Science Podcast. But if you want to learn more about knowledge at Los Alamos National Laboratory, check out the stories in our latest issue of the magazine. The links are listed in the show notes. Many thanks to writers Jill and Jake, and to technical trainer Daniel Garcia and the staff of the Net Academy.
For more great stories from Los Alamos, visit lanel.gov/magazine.